All right, we're going to talk about precision today, and your learning target is I can analyze and compare measurements for precision and accuracy. Okay, so let's start on some definitions. So first we're going to define what precision is, and precision is making sure measurements are taken accurately by using the smallest possible unit or fraction. Okay, and so an example of this, if we look at the number pi, okay, pi is 3.14, and it continues on and on and on, and it never actually ends, right? But a lot of times we just talk about pi being 3.14. Okay, but if I were to take a look at pi as in 3.1415, if I'm asking you which decimal is more precise, we're talking about the smallest possible unit, and because this has so many decimal points after the decimal, or after so many numbers after the decimal, that means that this number is more precise. Okay, so when we're talking about being precise, we're taking the smallest possible unit or a fraction. Okay, same goes with if I were to say that I took 10 free throws and I made 9 of them, or what if I said that I took 900 free throws and I made 90 of them, right? Obviously, the one that is going to be more precise is going to be the one with the larger fraction, okay, which would be 90 over 100. Okay. And then accuracy is how close the measurement is to the actual value of whatever is being measured. Okay, let's do some examples. Okay, example 1 says to choose the more precise measurement in each pair. Okay, so for A, it says we have 3.4 centimeters or 3.43 centimeters. All right, now 3.4 centimeters, that goes to the nearest tenth of a value, where 3.43 is to the nearest hundredth. Okay? Now, because hundredth is a smaller, more precise measurement, it's going into more detail, we would say that the more precise measurement then would be 3.43 centimeters. So 3.43 centimeters is the one that is more precise. Okay, now, but B here, we've got 3 feet or 36 inches. Now, 3 feet and 36 inches are the exact same measurement. It is the exact same measurement. 36 inches is equal to 3 feet. But if I'm asking you which one is more precise, then we have to use the one that is using the smallest measurements. Now, feet are a little bit larger than inches, right? There's 12 inches in a foot. And so because inches are a little bit, they're closer together, we're trying to really take a look at a closer value, we would say that 36 inches is more precise than 3 feet because of that reasoning. Example 2 says that Sam is a technician in a pharmacy lab. Each week she must test the scales in the lab to make sure that they are accurate. She measures the box that is exactly 5 grams. Okay, we just know that this box, whatever this box is that she puts on the scales, it is exactly 5 grams. And she does it 3 times and she gets the following results. The first time she measures it, she gets 5.01 grams for the scale. Or the scale reads 5.01 grams. The second time on the second scale, it says 5.033 grams. And on the third try, on a third scale, it gives us the weight of 4.98 grams. Okay, and so the question is which scale is the most precise? Which one is the most precise? And if we're looking at all 3 of these here, we can see that this first one goes to the nearest hundredth place. The third one also goes to the nearest hundredth place, but the second scale goes to the nearest thousandth place. Okay, so we would say that scale 2 is the most precise because the decimal goes to the nearest thousandths. All right. Now let's stop this and move down to the second part of this question. Okay, B says that we want to find out which one is the most accurate. Okay, so how far away is it from the exact measurement? And how we use that is we use that with absolute value. Okay, we take the measurement of, let's do scale 1 first. This is scale 1. And we know that the measurement of scale 1 gave us 5.01. And if we subtract that from the actual amount, which we know it's just 5 grams, we will find that the difference is 0.01. Now for scale 2, we're going to do the exact same thing. We're going to take 5.033, subtract that from 5, and we're going to get 0.33 grams. We can label these. And on the third scale, we took 4.98, we subtract 5, and we get 0.02 grams. Okay, now if you need to, you can use a calculator to subtract these out and find what the absolute value is. Again, absolute value makes everything positive, right? So let's go ahead and move this up. Now if we take a look at this, because this one is 0.01, scale 2 is 0.033, and scale 3 is 0.02 grams away from the actual value of it. Let's order it from least to greatest, right? And we know 0.01 is the least. That is less than 0.0. And if we look here, these are the same, but if we go to the 100th place, 2 is less than 3, so 0.02, which is less than 0.033. Okay, so we've ordered it in this way, and because 0.01 is the smallest away from distance away from what we wanted was 5, that means that that scale is the most accurate. And remember, that is scale 1. So scale 1 is the most accurate scale. Okay, that's all we're doing here for this lesson. Hope you enjoy it. Keep it real.